We want to be CSU's first undergraduate student group to launch a CSU satellite.
Our goal with OpenOrbit is to bring the electrical and computer department to the table when people think of aerospace, because that's what satellites need.
A CubeSat is a small satellite that fits into a form factor that's standardized between all CubeSats so they can fit into a modular size.
Managing heat is definitely one of the primary challenges of building a satellite. Cooling down is typically what's thought of as a problem in space, but in reality, the problem is actually switching between hot and cold at such a regular interval.
Honestly, the biggest thing that we've learned from the atmospheric conditions, you're never going to be able to really predict it. And we've had to put in a lot of work to be able to figure out where the balloon's actually going to go so we can go pick up our payload.
We firstly utilize AI for some of our decision making and determining, researching, I guess, for many of our projects. And then we have a specific payload that we're using AI on for cloud recognition.
You know, you'd think if you want to go higher into the atmosphere, you'd fill it up with more helium. But in reference, you'd fill it less because the more helium there is, the quicker the balloon pops.
Something that works really well around here is when somebody puts out an idea and the whole room lights up, and then it's like off to the races.
I do want to spend as much of my life as possible building space robots. And that's my my whole thing. And this club, it really helps put that together.